Have you ever considered tuning your CAD workstation to gain more performance? And if so, can that overclock be stable? G'day viewers. Today we are taking a look at new PC components for a high performance CAD workstation, which we are building with the express intention to evaluate out-of-the-box stock performance against the productivity of a stable tuned system. Topics we will cover in today's video are why we are building a new high performance workstation, software considerations, our selected components, the PC build itself, and costings in Australian dollars. To explain why we are building this new workstation, I firstly need to highlight what has changed with our advanced steel workflow that has prompted this build. Over the past few years, we have developed and improved our documentation automation system, particularly for advanced steel. As a result, the SysDef Advanced Steel solution has allowed users to run automation processes to create a full set of engineering drawings and a full set of workshop drawings from a single script. For a small project, this might be 100 drawings. For a large project, you might need to create several thousand drawings. In either case, automating the process to create drawings will save users days, and on larger projects, weeks worth of work. So, why does this change require a new workstation build? Speed. Speed is the simple answer. These scripts can take 15 minutes to several hours to run. As a byproduct of the automated outputs, what has been interesting is the newfound ability to also use these automation processes for auditing of models. The benefit to the detailer is that it provides the confidence that once the 3D modeling is completed, the documentation is not going to cause any grief, as issues can be resolved during the 3D modeling phase and not discovered at the end, close to a delivery deadline. The downside is that the drawing automation process is no longer run just the once at the end of a project, but rather it is used several times throughout the project to audit 3D models. It assists with finding stray welds or stray bolted connections, incorrect model rolls, or drawing styles that may need to be tweaked. This new workstation will allow audits and 2D drawings to be created significantly faster than existing mobile workstations. Let us consider the software to be used on the CAD workstation itself. We use mainly the Autodesk AEC collection, which has Advanced Steel, Revit, Robot Structural Analysis, Navisworks, Recap, AutoCAD, and Dynamo. Plus, we use plugins for advanced steel such as the Graytec Power Pack, Titan Pro, Idea Statica, and iConstruct. Other software that I use are programs like Camtasia, DaVinci Studio, the Microsoft suite of products, and soon, hopefully, OBS. The core purpose for this new workstation is to run single-threaded CAD software, which we all know craves a high-frequency CPU. We also know that CPUs that offer the highest available frequencies typically have a lower core count, mostly due to thermal limitations. Although this workstation will be undertaking some video editing and rendering operations from time to time, which would benefit from having CPUs with a higher core count, its primary focus will be with advanced steel, modeling and automated drawing production. I think it's worth mentioning that both iConstruct and DaVinci Studio have functionalities that can take advantage of NVIDIA's GPU CUDA cores for parallel processing. Other than some GPU processing with Revit rendering, the majority of these other CAD software applications don't harness the available GPU resources and purely use the GPU for graphics display purposes on the monitor, which is most disappointing. I haven't started to use OBS in my current workflow, so I don't have much insight into its resource utilization. If anyone has experience with OBS and whether it uses GPU or CPU processing, I'd be interested to understand that software application resource needs. If you have any advice, post your comments below. Rightio, let's get serious now and start reviewing these exciting new PC components. This PC build will be known as AB, also known by some as Captain Cranky. Here is an overview of AB's build specs. For the chassis, we have gone with the LIAN Dynamic 011 Evo. For the motherboard, we've gone with the ASUS ROG MAXIMUS Z690 Extreme. The processor, we have chosen the Intel Core i9 12900K processor. For the CPU cooling, we have gone with the ASUS ROG RYUJIN 2 360 all-in-one liquid CPU cooler and 9 LIAN AL120 fans. The RAM, we have gone with 64 gig of G.SKILL DDR5 RAM at 6000 MHz. For the GPU, we have gone with the NVIDIA QUADRO RTX A4000. For storage, we've got two 2TB 980 Pro M.2 SSDs in a RAID 0, plus one scratch drive, which is also a Samsung 4TB SATA SSD. The operating system, we are using Microsoft Windows 11 Pro. The power supply, we have selected the CORSAIR HX1000, which is a 1000 watt platinum PSU. Thermal place, the NOCTUA NT-H1 thermal paste. With monitors, I've gone with one Dell 43-inch ultra sharp 4K monitor, model number U4320Q, plus two Dell 27-inch 4K monitors, model number P2721Q. So that is a quick overview of the parts that this workstation build will have. I will go through the parts list in the order I made my decisions. I found this selection method assists with the process of elimination when selecting the components. Other factors that played a part in the selecting of components were availability and which brand some suppliers held. Initially, I had selected 3 potential PC part suppliers, 2 that were local bricks and mortar stores and 1 that was an online national supplier, with the intention of ordering from whomever had the best price for each specific component. In the end, that proved to be more challenging than the value that it offered. So in the end, 95% of the components were purchased through the one supplier, with only the DDR5 RAM being difficult to source and purchased through a separate supplier to ensure we had those components available in time for this build. GPU stocks were still proving to be difficult at the time of this build, which is late February 2022. However, I was lucky and I didn't have an issue with sourcing my GPU at the time of this build. The CPU is the brains of the workstation, so this was my starting point for the build, with the 2 options being Intel and AMD. Intel has the new 12th gen processor and AMD has the Threadripper and Ryzen 9 models. The 12th gen Intel uses the 1700 series socket, while the Ryzen 9 uses the AM4 socket, which has been in service since 2016. The Threadripper has the TR4 socket, which has been in play since 2017. For me, holding socket architecture for longer periods is, in my opinion, a smart move by AMD. Intel, on the other hand, choose to change their socket sizes constantly, which prevents consumers from upgrading to newer CPUs easily, with having to swap out motherboards when upgrading CPUs, or just buying a whole new rig. As much as CPU frequency is the prime factor when selecting a CAD workstation CPU, a less considered spec is its capacity for instructions per cycle, or IPC. Even though the current AMD CPUs have a slower clock speed than Intel, they hold their own due to having an advantage with IPC. The AM4 socket is due to be discontinued after many years in service, with the much anticipated release of the AM5 socket later in 2022. When it comes to multi-threading applications, particularly video editing, rendering and point cloud processing, I would say AMD currently has the upper hand, which makes for a tough decision to select a CPU for a workstation that requires performance for both single-threaded and multi-threaded applications. With the end of life of the AM4 socket and the core focus of Captain Cranky to be a single-threaded workhorse, I eventually chose to go with the Intel Core i9 12900K processor to be the brains for this build. Let's take a look at the specifications and the stock out-of-the-box values for the performance cores. It has 16 performance cores, 8 performance cores and 8 efficiency cores, for a total of 24 threads. Performance cores have a base frequency of 3.2 GHz. Performance cores max turbo frequency is 5.1 GHz. Performance cores with the technology 3.0 has a frequency of 5.2 GHz. To summarise this technology, as I understand it, Intel has built-in checks to find which of the 2 performance cores are the strongest, and allows those 2 cores to boost to 5.2 GHz as a stock out-of-the-box function. These cores have been termed the golden cores. I'm yet to establish whether that stock function is a constantly changing and evolving selection, or to nominate the golden cores, the physical silicon is the determinant factor. Something else to note is the Intel 12900KF variant doesn't have the integrated graphics that the 12900K has. This extra graphics function should allow me to run an extra screen to monitor the resources and free up display ports on the GPU. How best to set up my system to utilize the 8 performance cores and 8 efficiency cores is yet to be determined. So hopefully our testing will shine light on our options to gain the most performance. I plan to do a separate video on our testing and those test results, so keep an eye on this channel for future videos on that topic. If the CPU is the brains of the computer, the motherboard must be the nervous system, allowing all the PC components to talk to each other and transport messages to the brain via the bus lanes. As much as I probably should have purchased a workstation motherboard, I have intentionally gone with a gaming motherboard for a very specific reason for this build, and that is I plan to test and evaluate any productivity gains that may be available for CAD applications when overclocking. The reason workstation motherboards are typically a better choice for CAD applications is due to them having additional PCIe lanes when compared to gaming motherboards. For this build, the motherboard that I've chosen is the ASUS ROG MAXIMUS Z690 Extreme. Let's point out some of the key features this motherboard has. It has the 1700 series socket for the Intel 12900K processor. It has 4 DDR5 RAM slots, 1 DIMM.2 slot, 2 PCIe 5 slots, 1 PCIe 3 slot, 5 M.2 slots, and 6 SATA ports. For the rear I/O panel, we have 1 Thunderbolt 4 port, we have 1 USB Type-C 3.2 Gen port, 8 USB Type-A 3.2 Gen 2 ports, 1 HDMI port, 1 Wi-Fi 6E module, 1 2.5 gigabyte Ethernet port, and 1 10 gigabyte Ethernet port. As good as this motherboard is with its high specs, it still has some quirks. How it handles the dropping of PCIe lanes when loading it up with PCIe 5 components is still a bit bizarre to me. Thankfully, there aren't any PCIe 5 GPUs or M.2 SSDs available just yet, as this would limit my options to a point, but not enough to switch back to a workstation motherboard for this build. With the addition of the Thunderbolt 4 port, connection to an external Thunderbolt storage NAS would be a space for us to watch. Just to note, the Thunderbolt 4 has the same specs with regards to speed as the Thunderbolt 3, but Thunderbolt 4 is bi-directional. Personally, the critical feature that this motherboard provides will be with its simple interface it has with the BIOS to assist with system overclocking. The ASUS version for the BIOS management interface via the Unified Extensible Firmware Interface, or UEFI, is the first application we will be using to manage the hardware settings. The second application we will be using is the ASUS ROG AI Suite 3. This application can manage and monitor basic system overclocks. How each of these two applications work together to manage the BIOS is what we need to investigate once we have our build available for testing. This is a whole new tech space for me, so I am super keen to see what productivity gains can be found. Maybe we will find that only Bitcoin miners and gamers benefit from overclocking. However, I am keen to see where this investigation ends up for this current generation of technology or future generations. The main job of video cards is to prepare and send images to display monitors. However, due to its parallel processing architecture, they are well suited to other math computations. A CPU might have 16 cores, however a GPU can have several thousand cores. The GPU uses parallel processing to increase simultaneous computations. This is why Bitcoin miners use them, which is why CAD users are having trouble getting hold of them. Not only can GPUs be used to render images to be sent to monitors, they can be used to improve computational times. However, the software developers need to write that functionality into their code. It is very possible to have single-threaded software like AutoCAD that have some GPU or some multi-threaded functions. We don't see much of this type of coding from Autodesk, and if you ask them, you will get a long list of reasons why they can't. Yet, a small software development team in Perth wrote GPU processing functionality inside Navisworks. So it is proven it can work and saves users huge amounts of time and increases productivity. There are two schools of thought when it comes to video cards: consumer gaming cards and professional workstation cards. Some key points to consider when choosing your video card. Gaming cards were once much cheaper than QUADRO cards. However, with Bitcoin mining driving up these prices, of consumer grade cards, the differential is not as vast as it once was. QUADRO cards typically have more VRAM than gaming cards, and QUADRO cards tend to be more power efficient. QUADRO cards have a much smaller form factor, so they take up less space in your case. QUADRO cards have a blower style fan, which is different to gaming cards, and they have several display ports, not HDMI ports like gaming cards. Workstation cards have better support from CAD software vendors. However, after all my years in the industry, I'm still yet to meet another user that has actually had to lean on that support offering, although I'm sure they exist. After much consideration, I have selected the NVIDIA QUADRO RTX A4000 to be my next GPU. Over the past few years, I've been watching how much my GPUs have been working, and it is very surprising to see how little work they actually do with 3D CAD applications. I've always had in my mind that CAD software could not get enough GPU processing power. Turns out 3D CAD software doesn't need all that much GPU power after all. So why then get an RTX A4000 card when my current 4GB GPU is still not end of life? Well, let's take a look at its key specifications. It is a 16GB video card with 4 display ports with a max power of 140 watts, and it is a PCIe 4 card. I would have considered using a cheaper RTX A2000 if I could get hold of one, but I couldn't at the time of ordering. Plus, I would like to see if I can get iConstruct and video rendering applications to get this GPU working harder to earn its keep. When it came to selecting the CPU cooling, I've gone against all my research learnings and selected an all-in-one cooled solution. Essentially, it is an off-the-shelf, self-contained liquid radiator. From everything that I have read, air cooling is as good as water cooling for stock standard PC builds, and they are much less prone to failure. Simple is best is what they always say, so I hope this choice doesn't come back to bite me. 3 factors pushed me away from logical reasoning. The first being that the PC case that I selected, its design had water cooling in mind. Secondly, I've never had a water-cooled workstation before, and I'm interested to see how it goes when put under overclocking conditions. And thirdly, it has a 3.5-inch LCD screen that will monitor the CPU temperatures, among other sensors. The third reason might need to be taken with a grain of salt, as I've ordered 2 separate temperature monitoring devices. And furthermore, it is my understanding that the temperature displayed by the RYUJIN 360 is actually the socket temperature and not the core temperatures. So this is something to be aware of and to keep in mind when we do our testing. In addition to the radiator cooling, I've gone with 10 fans. I've gone with LIAN 120mm fans. I like the design and the modular connectivity and the simplified wiring that they have. I'm yet to decide which software application I will use to control the fans, as LIAN has their own software and ASUS has Armoury Crate, which has some clever features to manage the fan curves. After hours of research of different fan installation configurations, my current strategy is to have 9 intake fans and just the 1 exhaust fan, which will provide positive pressure in the case. My hope that there will be enough vents and gaps in the chassis to exhaust all the intake air pressure. I had considered using the power supply unit to act as an extra exhaust fan, but I'm going to hold off on that theory just for now. I will install the radiator vertically as a side mount with 3 fans. On the top, I plan to have 3 intake fans, and on the base, I plan to have 3 intake fans with the 1 exhaust fan low at the back of the case. So that's a total of 10 fans. Now the LIAN fans come with packs of 3, so I will use one of the fans that come with the radiator to pick up the shortfall with the exhaust fan on the back. With the 2 leftover fans, I might rig them up externally to the case to push exhausted air away from the case to prevent any short cycling back into the air intake fans. Still a theory at this point and not very scientific. I don't have much research material on thermal paste, and I don't envisage this playing a significant factor, as in my opinion all the good brands would perform equally well. My selection of the NOCTUA NT-H1 was based purely on availability from the supplier. DDR5 RAM for me was the most challenging component to source at the time of my build, which is mid-February 2022. It was one of the few items that I couldn't procure with the majority of other PC components. After much hunting, I selected the G.SKILL DDR5 RAM. It came in 2 options, a RGB and a non-RGB. I wasn't particularly interested in the RGB version, however, it was $100 cheaper than the non-RGB version, so in this occasion, price won for this selection. Key specs for the RAM were its DDR5 RAM, its frequency is 6000 MHz, its timing of 36, 36, 76, and it is non-ECC RAM. The interesting point that I found when hunting for RAM was the RAM that I found with the lower timing values was slightly cheaper than the RAM with higher timing values. Now, lower timing values for RAM, in my understanding, is better. It had me confused when purchasing, so I looked deeper to see if there were any other component specs that might be influencing the price. But I couldn't find any, so that will remain a mystery to me. Computer RGB bling is not really for me, so we will see if this RGB RAM plays with my OCD and I can live with this life choice. You will know if you see me advertising cheap DDR5 RAM in a few weeks. So stay tuned, someone might get a bargain. As a side note, a few forums have noted that using XMP 3.0 settings with the Intel 12900K has caused instability and boot issues, including the dreaded blue screen of death. It is something that we are aware of and need to watch for BIOS updates for the motherboard and further understanding of the cause, particularly with our intentions to reduce instability via overclocking. I did look long and hard into modern PC case designs and different functionalities. The current range of LIAN case designs are, in my opinion, a well thought out product line and offer plenty of flexibility. My second choice case, which was my original number 1 choice when I was still planning on doing an air-cooled build, was the LIAN Mesh 2. After wrestling with my choice of CPU cooling selection, the LIAN O11 Dynamic Evo finally got the nod. Apart from the fact the O11 Dynamic is specifically designed with water cooling in mind, the option to do an inverted motherboard build to allow me to position the case on my left-hand side was a major consideration. My only concern with the Evo is it is a mid-tower, not an XL case, so I'm wondering if an XL case would have offered more space and better cooling. I did take up the option to get the top USB hub and an extra hub, although the motherboard only has the one USB-C header, so I will only gain extra USB-A ports and not extra USB-C ports. I'm looking forward to getting this case out of the box and having a good look at this case with its multi-build options, as it has plenty of flexibility. With the ASUS ROG MAXIMUS Extreme motherboard having so many options for storage devices, it became quite a challenge to find a sweet spot for storage. My main consideration with storage, from what we have found more recently when using SharePoint and the Autodesk Construction Cloud services, is the capacity to store locally cached files. This, plus the ever-increasing capacity to store software application program files, particularly with having to install and maintain a minimum of 3 years worth of the AEC collections, it takes up quite a bit of space. I haven't resolved all my long-term storage solutions or have a strategy for storing video editing and rendering files like today's video, as they are considerably larger files than our CAD files, with the exception maybe of point cloud data. For my operating system and cached cloud storage files, I plan to use two Samsung 2TB 980 Pro NVMe M.2 SSDs paired in the ASUS DIMM.2 module slot and run in a RAID 0. This will give me 4 terabytes of capacity with super fast read and write speeds. I may consider installing a PCIe 5 SSD when they are released later in the year. However, that will affect my other PCIe slots due to how ASUS have engineered the PCIe lanes and the bifurcation arrangement. I will have an additional Samsung 4TB 2.5 scratch drive for extra storage space, which normally gets filled up with junk files and backup files. Based on some basic calculations we did, I reached a power consumption of just over 600 watts. So I decided to go with a 1000 watt power supply unit to give me some redundancy for future components or to use in another build down the track, as the PSUs are fairly universal components. To assist with our testing, I've also purchased a power usage meter to monitor the power at the wall against the values shown in the hardware resource monitoring software as a bit of a secondary audit. I can't seem to get enough monitor real estate, partly due to not remembering how to use the Alt-Tab function, plus I do like to be able to see everything while I am working. It's just an old habit. Currently I am using dual 34-inch ultra-wides at a 21:9 ratio, plus a laptop screen. My ever-growing number of advanced steel toolbars, pallets, custom pallets, plug-in pallets continue to eat away at my on-screen workspaces. I looked into the option to go into the world of super ultra-wides like the curved Samsung 49-inch monitors. A couple of things put me off. The curve seemed to pick up light reflections, and it had a real letterbox feel with it being so long and narrow with its 32:9 ratio. For my new build, I've chosen to go with a 3 monitor setup, one 43-inch and 2 vertical 27-inch displays. For my main monitor, I have selected the Dell 43-inch Ultra Sharp 4K with a 16:9 ratio. This monitor has a horizontal screen length of 960mm, but more importantly, in my opinion, it has a vertical screen dimension of 560mm, which is almost double the vertical dimension on my existing 34-inch ultra-wides. This is the display real estate that I hope to really take advantage of by using the new Power Toys feature in Windows 11 called Fancy Zones. This feature should allow me to customize my 43-inch screen to optimize workspace zones. This is a 4K monitor running at 60 Hz. Good for CAD work, but unlikely to satisfy gamers looking to run blazing 4K resolutions at 144 Hz. The 16:9 ratio was important as this helps for screen sharing when on video meetings or running remote software tutorial classes. The Dell 43-inch monitor is a DisplayPort monitor, which matches my NVIDIA RTX A4000 video card, which has 4 display ports. it has additional ports for HDMI and 2 USB-C ports, which will come in handy. It has built-in speakers, so that will save me having to run additional cables for those, plus a power source via a 90-watt USB-C port that could be used to charge a phone, laptop or tablet. The 2 vertical side monitors I've selected are 4K 27-inch monitors from the Dell P series. These have an ultra-thin screen bezel, so it should work well in a portrait orientation. These are also DisplayPort monitors running at 4K at 60 Hz, again in the magic ratio of 16:9. These Dell 27-inch monitors are compatible with the Dell MSA20 monitor arms. Now that I have selected a giant 43-inch screen as my main monitor, I'm short of desk space, so to gain back some desk real estate by using monitor arms is the plan, rather than buying a larger desk. I've never run vertical monitors in the past, so it will be interesting to see whether both stay in that orientation or one or both end up back in the traditional landscape position. Time will tell. Well, aren't cables an interesting and complex topic? All cables are equal, but some cables are more equal than others. It is such a complex area that I am considering doing a separate episode just on cables. After my recent discovery of what an active cable actually does for converting DisplayPort to HDMI signals, I was armed with far more knowledge when it came time to selecting cables for AB. After looking into cables and getting dodgy advice from my friends at Hardly Normal, I have found a reliable source of quality cables and adapters. My supplier of choice for this build was Lindy Cables, and more specifically the Anthra line of cables. Not only do they supply quality cables, their phone support service has been top shelf. Some key finds regarding cables. DisplayPort cables, versions 1.2, are good for 4K at 60 Hz, which matches my monitors. HDMI 2.0 can handle 4K at 60 Hz. USB-C over 3 meters needs to be an active cable, and I can tell you they are not cheap. Keep an eye out for future videos on this channel that will go deeper into cable specifications. Everyone has been doing plenty of video meetings in the past 2 years, so webcams deserve some attention. Coming from a mobile workstation, I didn't have a dedicated webcam, and older laptop webcams aren't great, which I didn't realise until someone kindly told me one day that my image at their end was dark and pretty ordinary. For that reason, I have selected the Logitech 920E webcam, specifically due to its ability to provide a decent video image in low light, which it seems my office has. The 920E is also a 1080p camera, so this should offer a decent resolution for any of my future video tutorials. I have kept my old Logitech MK850 keyboard, which I've been using now for around 6 years and still comfortable using. However, I have decided to give the 3D Connection wireless space mouse and CAD mouse another crack. I am aware of the issues that the space mouse has with interfacing with advanced steel. However, in the interest of giving it another chance, and in the hope that Autodesk and 3D Connection can eventually find a way to hold hands and play nice, we might at some point have a fully functional 3D space mouse, which would be a welcome change. I have also kept my old Rode USB NT microphone. It still performs very well for a basic USB mic. For speakers, I will wait to see whether the speakers on the new 43-inch Dell monitor cut the mustard. So most professional PC builders could probably build a PC with just a Phillips head number 2 and a few simple tools. However, I've got a few different things here that I've put together for what I want to use for my build. So I do have some screwdrivers, so a typical Phillips head number 2 screwdriver, and this one is just a little bit longer than your normal short ones, which does help to get into those deeper screws if you need to. Now, this is a screwdriver magnetizer, so using this to magnetize your screwdriver makes it easier to hold on to screws, so that is handy. I think a flathead screwdriver may be handy. I think that can help to pry things open and get to places, so that particular screwdriver will be handy. This is a ratcheting screwdriver, so it does help speed up the process. Now, this particular ratcheting screwdriver does have some different parts. So it does have a bit for a Phillips head number 2. It also does have a Phillips head number 3. It does have some flatheads and some square drives as well, should we need them, which I don't think we will. Now, the interesting part about this particular screwdriver is that when these come out, they have an impact driver end on them, so you can swap them out and put some of your extendable impact driver bits in there should you need to have a longer screwdriver. So this one here is approximately 250 mil long. So should you need to get into a deep spot in behind somewhere, that just does help you have that extra reach if you need it. Now, scissors just for cutting anything in that need to be cut, opening boxes, measuring, just a steel ruler. This is only 150 mil long, so if I need to measure something or work out what size a screw hole is, we'll do any of that. A box cutter. This is a hook box cutter. I like it for opening boxes. I think it works well. A marker pen. I think a marker pen is always good if you want to make a note or write something on a component that you want to come back to. Long nose pliers, always handy for getting into those little tight spots. Now, these particular components or these tools are just little small pieces, good for doing work on electrical builds. We've got a torch, so we've got a torch here to if we want to sort of see into the back of somewhere or get into a dark spot, we've got a bit of light we can shine into a spot should we need. Center punch, should we want to mark a hole. Hopefully we won't be drilling anything today. Cable tie management, we've got some zip ties. So we've got a range of zip ties. So these are just a medium size, or what I call a medium size zip tie. Bit of lecky tape in Defaust blue, and different types of Velcros. So this Velcro tie, these are quite good. They're not the cheapest, but they're probably the better type of Velcro ties. Very handy. These are just yellow ones. I'm not sure if I want to use yellow ones in this particular build because they're going to stand out and look a bit awkward in the case. And just a roll of Velcro so I can cut things to size should I need to have a bit of extra length for some cables. Probably won't need it, but we have it on hand. We've got just a container for putting loose items so they don't roll away and fall on the floor. When you spend half a day looking for a particular screw, which I I don't think will be good. Now we've got this tool here, just in case there are any Swedish components that come into our build today. I think most of the components are not coming out of Europe, so we may not need that particular tool. And we've got the 8-ounce persuader. Now, if things get really bad, this will be coming out, but with all our planning, I believe we should be spared from having to use the persuader today. So those are the tools that I've selected for our build. I think that they should be enough to get us through for today. Hopefully the persuader stays out of the build. So with that, we might roll up our sleeves and can kick on and get the build started. So just to make a note, in the top of the Lian Li 011 Evo case, for transport there are a couple of number 2 Phillips head screws that hold in these side panels. So it's worth putting them in if you're going to be transporting this. However, if you want access to your case regularly, then I would leave them out. In my case, access to the side panel, I believe I'm going to want fairly regularly. The front panel, I don't believe I'm going to be wanting to get off regularly, so I may put that screw back in the front there to lock it in. But worth a note. Okay, so we now have our 2 Samsung 980 Pro NVMe M.2s on the motherboard with the 4 sticks of RAM, and the CPU is now locked in place, but it doesn't have any thermal paste on it just yet. Our next step will be to attach the backing plate for the RYUJIN water-cooled plate. So we're going to mount that on the back. So let's do that. Okay, so we've got that cover back on. I think we'll break for lunch now and come back and complete the build. So we've now got the majority of the major components into the case. We've got the radiator with the 3 LIAN fans as an intake, the 3 bottom intake fans and the 3 top intake fans. We've now got the CPU cooler with its cover and its 3.5-inch display LCD screen in place, with its with the water pipes there. we've now got the back cable management panel off. So now we'll get into doing some cable routing and some cable management. Okay, so we've now completed the hardware build itself and finished installing the components. So the last few components that we have installed are the PSU. We've installed the PSU with the cabling. We've installed the scratch hard drive, which is a 2.5 inch scratch drive on the back. We've installed the fan controllers on the back to obviously control fans, and hooked up the bottom I/O adapter, as well as the top mounted I/O adapter. So the major components are now all connected. And obviously the hardware build is complete. So we have the motherboard in, the GPU is in, the DIMM.2 adapter is in, the CPU cooler is in. We have our 10 fans, so we've got 3 LIAN fans across the top. We've got our radiator in the back with 3 LIAN fans in the front and 3 LIAN fans in the bottom. Those LIAN fans are all 120mm fans. So, and we have got one additional NOCTUA fan, which was supplied with the radiator, or for the radiator in the back. We've used it as our single exhaust fan on the side over there. So now our cables are connected from the motherboard to the PSU, the power unit. So essentially, with the hardware build is now completed, and we are ready to do its first power on self-test or post to check to see if we can get it to post, and to get to the BIOS to check that all the components are running well, and we can check the temperatures and some of the checks to make sure everything is fine. So with that, we will turn on the main power source. So the main power source to the build is now on. So hopefully we're getting some lights. Okay, so we're getting some lights on the front. That's good. The CPU is now turned on. The motherboard is turned on. So we'll now fire up and do a post. So we've got some lights happening, so that's always a positive. So while it's posting, it should go through and do a series of checks. So far, so good. Right, okay, so it's done its internal checking, and the BIOS has booted. So I'm just going to check now to see what that's telling us. So everything there is looking okay. We've got our frequency, so it's telling us our frequency at the moment is our top frequency is 4.9 megahertz. Its current running temperature is 25 degrees. Its core voltage is 1.27 volts. Our RAM is currently running at 4,000 megahertz. It's also telling us our capacity for our DIMM.2 drives here is 64. Oh, sorry, that is our capacity for our RAM. So we've got 4 sticks of DDR5 RAM, which is 64 gig there of RAM. So everything there is looking well. So that's good news. So I'd say we've now had a successful post. Our next task is to power down and we'll insert a flash drive with Windows 11 and some additional drivers to enable the DIMM.2 adapter to run in a RAID 0, which is how we've set it up. Something else I think is worth mentioning is with setting up our fans, what we have found is that we've had to run 2 fan controllers. So we've got a fan controller which that came with the LIAN Li fan. So we have our LIAN Li fans connected to a LIAN Li fan controller, which is also connected to a USB header on the motherboard. But we've got that, what I'm calling controller number 1, also connected to a secondary fan controller, which is receiving some messages from the all-in-one CPU cooler via a USB connector, which is connecting that controller to the LIAN Li controllers, which should give us the ability, once we're into the system later on, to determine how we want to control the fan management once we start doing overclocking. So we should be able to check, or we should be able to manage our fan ramp speeds and RPMs either via the LIAN Li software controller or possibly the Armoury Crate fan control system. So which one is the best for managing those, particularly when we get into the overclocking process. We'll have to see what happens once we get into that, which one is best. So with that, I think we will now power down. We will insert the flash drive to get Windows 11 installed and the drivers. Once we've got Windows 11 in there, we can put all the covers on the top. So there's a cover that goes on top. It's a mesh cover that sits on top here. So obviously the fans are drawing through that. There is a side, well, that should be the front, so it'll be a front glass cover, and also there is a glass front, also that'll be a side cover here. So we'll install those. There's a mesh panel that goes on the back. Once that's all done, we can then take this case and move it to its final location in the office. So Captain Cranky is built, and Captain Cranky is still running at, what is he running at? He's running at 27 degrees, so he's calm and collected. So with that, we'll power down, get Windows 11 installed, which will be ready for us to start loading software and putting Captain Cranky to work.